And I just gave a presentation to a bunch of friends about this project of mine called Solarnet. And this was a group that was more toward the, let's say, nerdy end of the spectrum. And I am now recording that talk to share with you. So this is the talk that is for software engineer type people. If you don't know the game as well, this talk should be relatively okay for you. There are other talks where I'm going to really assume that you know the game a lot already. I'm going to try to clue you in a little bit on that here. So let's get started. There's the title of my talk. It's pretty long. I would never be able to use that title in an actual conference or anything like that, so I thought I would use it here. The short story is Terraforming Mars is this great board game that I like a lot. There's already a playable app for it. So in fact, there's two. There's a commercial app, and then there's the app that I like better, which is the open source online app, which you can find easily. Just search Terraforming Mars on GitHub. You'll find it very easily. But I had some ideas for how I wanted to build a game engine library from the inside out. I'm a very library-focused person. That's the way I think about things. So an app that's, a whole thing unto itself wasn't as interesting to me as something that I could build up from sort of first principles. And as we'll get into, I had some very different ideas for how to do it. So this wasn't just a sort of like copy what was already out there project. Anyway, you can judge for yourself. The main thing is I wanted something to work on that would be hard, and I got it. It fulfilled my every dream in terms of difficulty, I'll say that. Yeah, this is who I am. I've worked on the Java and Kotlin ecosystem team at Google. I've been doing it for 16 years, even though the team has been renamed a few times. I started that team 16 years ago, and I'm still doing it today. The point is that I have a kind of a libraries focus. I already mentioned this. If you've ever heard of a library called Guava, I spearheaded that thing a very long time ago. As far as hobby projects like the one I'm discussing today that are fairly complex and done by myself, I have taken on a number of those before, and that number is 0. I had no idea what I was getting into here. So this presentation is just to give you a sense of what I've done so that you can understand what questions you might want to ask me about it. I'll try to sort of discuss some of the design points and sort of give a sense of why it's designed the way that it is. So this is not just here's how to use it, here's how to start programming your own cards into it kind of a talk. And the demo is another video for another day, that's supposed to say. So I will try to get a better demo posted soon. Interesting things about Terraforming Mars. First of all, I don't pronounce it very well. Terraforming Mars. That's a little better. It is an example of a discrete game, which most board games are. And I'm not a game theorist, so I'm pretty sure that's not the correct term. But I'm talking about games that the entire way that the player plays the game is by choosing an option from a countable list of options. So this excludes things like many party games. If there's dexterity, singing, real-time elements, all these things are not discrete games. But if the only way you play the game is like, oh, I have these 7 to 7 billion choices, and I can choose one of them as my move, that's a discrete game. And a lot of the concepts around how this thing is designed are general to discrete games, but not more widely applicable than that. So that's why I mentioned that. Also, given the popularity of Terraforming Mars, it's relatively complex. There are many people who would say it's not complex at all, but those people are playing, games that most people would never have heard of. It also has 500 or more unique cards and card-like things. So this is a key aspect of the game that made it challenging for me to design an engine for it, because I would need to figure out a way that I could deal with all those unique things without having to sort of code them all over and over and over again. The final very notable thing about this game is that there's a very excited fan community around the game. There's something about the game that really caught everyone's imagination, and the forums are full of people who've created their own fan cards, their own maps, their own complete expansions. it just has engendered that kind of passion for creating that I haven't seen in many other games. And so that's another thing that really motivated me to think about creating a library which all those unique fan creations might be able to be plugged into relatively easily. Those 500 unique cards exist when combining all the expansions that exist for the game. There's only maybe 200 of them, in the base game. And what I started to wonder is, how could I boil down the absolute essence of what makes each card unique to its simplest form? And I'll pick that thread up again in a few slides. To give you an overview of what my project consists of, it exists in 4 different pieces right now, which are different modules, Gradle modules or whatever they are. One provides the format for how component data is expressed. So I'm talking about cards, standard projects, maps, milestones, awards, colony tiles, etc. I have data formats for those things, and then I have a library API for how that information is presented to the client. So there's lots of things you might want to do where you would just need this part. Like you want to, say, run some statistical analyses on how many cards that have this tag also have this instruction on them. You can do that with just this component. Why it's called pets, I'll maybe mention later. The second module is called canon, and that is just the body of data of all the published cards that exist. And specifically, it's the published cards that I already have working in the engine. I tried not to put things in there that don't work yet. So there's about 365 cards at this moment in May of 2023. 365 out of 454 cards. And then there's a smattering of other things. I think all 3 officially published maps are all there. Anyway, the third and the part that I'm really going to be talking about today is the game engine library, and I'll get into what that is. The fourth part is a very bad command line UI for interacting with the game engine library, because you don't want to sit down and write a unit test every time you want to play around with something and see what it does. Now let's go into what a game engine is, or at least when I say game engine, here's my concept of how I define that. I think of it as the absolute distilled pure logic part of the game. Its only job in the world is to know the rules of the game. And that means who can do what when and what happens if they do. And to paint a more illustrative illustration, of what I'm saying here. If you go to the forums and you look at any rules question that someone posts, like, what happens if I put this thing on that thing, but there's a etc. What should happen? Can I do that? Can't I do that? Does it activate this power if I do? If you take any rules question like that, there should be a way to write code that speaks to the game engine, that sets up that scenario and asks the game engine what happens, and then there should be a way to interpret its result to get the correct answer to that thing. But you notice I didn't say you can just ask it to it and it tells you, because the game engine speaks in a very, very abstracted, low-level way. So there's a translation that you have to do to sort of phrase the question in the limited way that it understands, and then to interpret the answer that it gives. So I really was interested in this because it boils the game down to what I would call its essential structure of its mechanics. And it strips away all the chrome, all the flavor, all the everything. And it just boils it down to the core mechanics that make it up. And as I just alluded, it's a very low-level API. You would not, when you see the command line interface for interacting directly with the engine, you would never want to try to actually play a game that way. It would be a very miserable experience, because the language you need to speak with it's not oriented toward human usability. All right, so in order to have an engine, there's 3 things we have to have a representation for. We have to be able to represent a game setup, which is my term for all the parameters the players agree on before the gameplay begins. Like, which expansions are we going to use? Which cards are we going to throw out? Are we going to use this variant or not? Etc. Are we going to add these colony tiles that came from a fan expansion, and how many players will there be, that kind of thing. So this is, if you imagine like they have duplicate bridge tournaments. In certain games they have duplicate tournaments of. The game setup would be the thing that is the same across all those tables. And so that means even down to the exact shuffled order of the deck, I would consider to be part of the game setup. The game state is the part that changes throughout the game from the beginning to end. And it's all the information you would need to know about the game so that you could reconstruct a functionally equivalent game at a different time and place. So if you imagine you're playing with some friends and you need to go to lunch and then you need to go over to Jimmy's house and resume the game there, what all would you have to write down or keep track of so that you could get the game right back to the same condition it was in? A lot of this would be just taking a photo from the top down of everything. That'll give you a lot of the information, but it won't tell you everything. Games have various other things they want you to just remember, such as whose turn is it, and are they on their first action or their second action, and have they already raised their Terraform rating this generation or not. So the photo is not quite enough, but the photo is most of it. And the third thing that we need a representation of is a decision, which is the units of information that the players feed into the whole thing. They say, I am deciding to take a plant and not a steel or whatever. I don't think there's any card that does that. I'm choosing to spend a plant and not spend a steel. That's from a real card. All the choices the players make, we need some way to represent one of those things. Now, the engine's job is to act on those things. Once we have a representation for those things, the engine will do stuff with them. The engine consists of two functions. One takes a game setup and produces the initial game state. And I'm speaking conceptually here. I'm not saying if you go into my code, you'll find a library that looks exactly like this except the game setup. I'm speaking in terms of concepts. You tell it a setup for a game and it can calculate the initial state of the game. And then the second one, which is used much more often, for a given game state and a given decision by a player, compute the next game state that should result from that. Or throw up your hands and say, that's illegal, you can't do that. That's the other possible outcome here. Either a game state or a declaration that you are doing something illegal that you can't do. So the game engine, all it does is calculate game states, and all game states are calculated by it. So this sort of defines the necessary and sufficient responsibilities of a game engine. My game engine, Solarnet, is something I would describe as a reference engine because the only goals I have for it are to get it as correct as possible, keep it as simple as possible, and then over time make it as complete as possible in terms of all the officially published content for the game. In terms of all the different map areas and milestones and cards and everything, there's something like 750 different objects right now. So it'll take some time to get there, but I'm on my way. They all have asterisks next to them because, it's not going to be, especially simple. I'm trying very hard to keep it as simple as I can, but it's not that simple. Not right now. So I'm just sort of acknowledging that it's an aspiration, right? Goals are aspirations. But on the other hand, performance or usability, like being fun and easy to use, I am not prioritizing those things at all because you just can't have everything. And the way I see it, someone could always create a faster version of the engine in the future. But if they do, I'd like us to be able to test the two engines against each other and make sure that they both do the same thing, which is called parity testing. I think that's a good way to do things like this. Keep one of the implementations as simple as it can be at the expense of performance so that it's easier to review and audit and say like, okay, I know why it's doing what it's doing. I can be convinced of why it's doing the right thing. And then the other one can do any cheats that it wants to get higher performance as long as we keep testing the two and making sure they do the same thing. And this engine of mine basically works. That's the other interesting thing about it. It does basically work. I have 400 out of 500 cards working right now. So in order to make all those different cards work, We need some way to express what makes one card different from another. I mentioned this before. I want to boil down the essence of what makes one card what it is. And so here's an example of a card. This picture comes from the online app that already exists. And I will remind again that the online app that already exists, the open source app that you can find on GitHub, is excellent. It really gets the rules right. I find it very playable. It does not, it doesn't put all of its energy into being a flashy, animated, sexy UI like officially sold apps on Steam and iOS Store do. It just focuses on being functional, and I really like it. Anyway, this is what a card looks like from it. The printed cards look kind of similar, but they have other stuff in them, so I use this simplified form. I realized that in order to express what makes a card uniquely itself, I could create a language that is very closely related to the iconographic language that the cards already speak. This shouldn't be too shocking of an idea, but what surprised me is that the icons exist to be a sort of reminder to players, like give them clues and stuff like that. But as I tried to retrofit a well-specified grammar onto that icon language, I found that it went rather well. It's actually pretty close to what I would call a well-specifiable language or grammar. With the exception, a number of exceptions. There are a number of ways in which I had to make choices that made the grammar more well specified, whereas the printed game gets to kind of wave its hands a little bit. And one of the biggest ways is that whenever the printed game wants to just put an asterisk on these things, it can do that. Whereas my machine representation of this, it can't just say asterisk. It actually has to have a way of specifying everything. So when I realized that, and then I realized that one could, once I have a parsable language that can be parsed into an AST, we could write code, someone could write code, that walks that AST and actually generates this icon, like an image much like you see here. At least in theory, they could do that. And the idea that there could be a single source that an engine could play the card correctly, and we could generate this image, and we could generate even the English language instructions on the card, and then hopefully get a volunteer to do the same thing for other languages. That single sourcing really appealed to me. The idea that a card would have no choice but to do what it says it does. There couldn't be a bug where it just did something completely different. That was the genesis of a lot of my energy on this project, or the impetus, I guess is the word. And by the way, as far as I know, in the open source app, when they want to support a new language, they have to go through the whole list of 500 different cards and translate them all, more or less one by one. In my case, if we do this, there'll be more programming involved, but you would, not have to repeat yourself as much. I don't know if that'll ever happen, but I like the idea that it could. Here's some examples of what the cards look like if you're less familiar with the game. I'm not going to spend time pointing out anything in particular, but you can see that the icons are used in certain ways and they relate to each other in certain ways. And these things actually have pretty well-defined meanings that we can use. So a lot of the language that I developed is just a textual representation of that. And here's an example. What this says on the left is when this card gets played, then create 2 Terraform rating for the player of the card. Simple as that. This one has a production box on it. If it just had 2 pictures of titanium, you would just get 2 titanium resources. But because we surround it in a prod box, which is that brown background, it generates production of titanium instead, which means you are going to get that much every round. And then we also have a trigger at the end of the game. When the game is over and a little signal goes out saying end, that triggers the card to produce 2 victory points. Here's a more complex example. There's a bunch of different things going on in this card. There's an action that you see on the right with a red arrow, and that's represented in the language as you'll never guess, a hyphen and a greater than sign. I know it's very creative of me. That's basically what these things look like in the language. The language is going to get much more complex than this when it has to deal with more interesting situations, when it has to deal with those asterisks and so forth, but this is the basic idea. Now, all these camel-cased words that you see in here, like energy, steel, oxygen step, victory point, these are the names of classes that you define in the pets language. Classes work, since this is the geeky presentation, I'm assuming that you're familiar with some programming language that has classes, probably. And so these classes are just what you expect those classes to be. They can be abstract or concrete. They have names. They exist in a hierarchy, subclasses and superclasses. They do have multiple inheritance in my case. And you can declare dependencies from one class to another, which I'll show in a slide or two. Here is a diagram of the main components and their subclass relationships, and there's some dashed arrows for the dependencies that we're going to talk about in a bit. I just put this here in case you're interested in it. You can pause it and look at it, but it's not that important. What I did want to do at this point is go back to the idea of a game state, which is that thing that changes throughout the game, and break it down into its constituent elements. So we have the components, which are all the things in the game state. And so I mean obviously every resource cube, every tile, every card, but we really represent everything that matters to the game as if it's a component. So for example, you yourself, a player, you are a component. An individual hex area on the board is a component. What are other good examples? The front of a card is a component. The back of a card is a component. We model everything as if it's one of these things and it has a class name that's unique to it. We also need to know the locations of these components, or how they relate to each other. And the third very important piece is we need to know what are the pending tasks of the game at that point in time. If you don't know what the game is waiting on to happen next, you don't really know the state of the game. So a really simple example of this is if you ever see a chess game example, like in a newspaper, they used to have a chess column, or you're looking at a book and it wants to show you a chess position. You see the board with all the pieces on it, but below it always says white to move or black to move. And if you don't know which task, a white move or a black move, that game is waiting on, you don't really know the state of the game. It's very important to know that, or else you really can't analyze what's actually going on. So the pending tasks are what are the things that the game is waiting on. And if there are ever none of them, that either means the game is over or the game is broken. Those are the only two possibilities if there's no tasks. As we mentioned earlier, because this is a discrete game, the way the players play the game is by supplying a decision for each of those tasks, and for each task, there's some innumerable set of different decisions you could make. All you do to play the game is you choose between them. And the game state consists of nothing else but those three things. Now, we can talk a little bit more about what a component in this language. Did I mention that the language is called Pets? It's a dumb name and there's a dumb story behind the name. But that's what it's called, so what are you going to do? What we do is we bundle the idea of the component and the location together into one thing, which looks like a generic type. So hopefully you're familiar with Java or C++ or any of the many languages that have generic types. This is another example of a generic type system. What you see here in this example says city tile that belongs to player 1 and is sitting on the 3-4 coordinate of the Elysium map, which, if you aren't aware, Elysium is one of the expansion maps for the game. I recommend that expansion, by the way. But this tells you everything you need to know about a city tile in one type. It's not like you have to get the thing and then follow a graph to find the other things it relates to. It's all bundled in here. And what's especially interesting about a type like this in the pets model is that, first of all, it is a generic type, like I said, but also each type inside the angle brackets also represents a bona fide dependency. That means I could try to form the type city tile of player 5, but if it's a 4-player game, I'm not going to be able to create one of these things. In order to create an instance of this type that you see, that player has to exist. Player 1 has to exist, The Elysium map has to exist. It has to have a 3-4 coordinate on it. Most generic types are not generally like that. You can parameterize the type on anything. It doesn't care, is there, which one of that type is the one that I care about. That will become a little clearer in a few slides, maybe. So in pets, an instance of a component is its type. That means the type is all there is. There's nothing else about the city tile to know. There's no properties, attributes, elements, fields, variables. Boy, there's a lot of words for this thing, but there's none of those things. The type tells you everything you need to know to distinguish it from everything else. If two things have the exact same type, they're indistinguishable from each other. So, for example, I might have two instances of plant of player 2. And that's because I have, in game terms, I have two resource cubes sitting on my plant box, and I'm player 2. They have the same type because they are properly not meant to be distinguishable from each other. They are, perfectly equivalent, and that's why they have the same type. Since the type is all there is, that also means that all these component instances are automatically immutable. There's no way to set a value to something else. Types can also be described as abstract or concrete. And a type is abstract as long as any part of the type, either the part before the angle brackets or any of the parts inside the angle brackets, if any of them is abstract, the whole type is abstract. And if you think about it, that makes perfect sense, because abstract means there's not enough information to actually create one. And if we want to create a tile, we can't just say, create a city tile on Tharsis 3-4, because the person trying to do that would say, well, which player owns it? I can't put it on the board without knowing which player it's for. And if we say, give us a city tile for player 1, they're going to say, well, where do I put it? And furthermore, if we say a tile for player 1 on Tharsis 3-4, they're going to say, what kind of tile? A greenery, a city, what kind? So we need to provide a concrete type for all of those things in order for the component itself to be concrete. And we can only create it if it's concrete. We can only remove it if it's concrete. But we can count things of an abstract type just fine. There's nothing wrong with counting up everything of a type that is abstract. Because we have made every instance of everything in the game just a thing, the whole game state is a multi-set of things, or just a bag of things. That was the reason why I modeled the whole game in a very homogeneous way. Like, I aggressively homogenized all the nouns in the game so that they follow a similar shape. That makes it so that an entire game state is just a bag of these things. And that means that any change to the game state is just adding some of those things, removing some of those things, or that's it. That's all you can really do with a multi-set. You can add things and remove things. So that's very simplifying. I'll skip that. Here's some examples of dependencies. If you're going to have a tile, you better have an area to put it on. If you're going to have something of type owned, it's like a resource or a card or a victory point, you better know which owner owns the thing. And there are also these subclasses of card bound, like a tag, a card resource. They represent something that lives on a card, and so they have to relate to a certain card front. They have a dependency from card bound to card front. Each of these subclasses is a subclass of card bound, so it inherits that dependency automatically. The basic design, what do we call it? Design center, design choice of the language that I designed is complex nouns and simple verbs. So the nouns, I'll start with those, they can be quite intricate. They can have quantifiers. For example, it could be like, you are gaining 2 plants, but it's optional how many you actually gain. Or you're losing 4 plants and it's mandatory how many you're losing. So those are quantifiers. There are the generic types that I already showed you. I might need to add difference types to the equation, hopefully not. And these types can also embed predicates or requirements or filters directly into the types, which is something that analyzing the game content showed me how valuable this would be and how often it's necessary. And so I didn't take this choice lightly, but I got a lot of value out of it. Once we do that, the verbs are just like I said on the last slide: gain, remove, and count. That's it. And that is the value of having the entire game state be just a multiset. I won't belabor that point anymore. Here's an example card. Placing a city tile would be pretty straightforward, but the card puts an asterisk on it, which then we have to figure out how to represent what that asterisk is really trying to say. The text on the card tells us that there's a special requirement: must be adjacent to at least 2 other city tiles. Now, if we didn't care where it went, we might just say city tile on any land area. I realize that's not the default rule for a city tile, but if it's just like, hey, place a city tile anywhere you want, we would only need to restrict it to a land area, because you're not going to put a city on an ocean space, right? Or a water area, as we call it. But what the card really says is adds this requirement: adjacent to at least 2 other city tiles. So we want to put something into this type that modifies land area and filters it down to just the ones that we are okay with. And this is what that looks like. It's a mouthful. It's some gibberish. It's one of the longer, constructs in the language. But what it says is this city tile has to go on an area for which there are at least 2 neighboring city tiles, and those city tiles could be owned by anyone. That's just an example. You don't have to type the less than signs in the color that I used here. That's just to help you see how they relate. I'm really not a type theorist. I'm aware that this resembles the idea of a refinement type, but I think it's probably a bogus example of a refinement type. I don't really know what I'm talking about. I just make this stuff up as it seems to suit the needs of the game. And as long as I'm showing all this weird gibberish, I'll show you an example of how things like the temperature track and ocean tiles are defined. All the nouns in the game have a class declaration like this. The actual engine code itself, the code that I have to write I'm actually implementing it in Kotlin. That code doesn't really know anything in particular about global parameters or greenery tiles or plants. Those things are all defined in this language that I developed, which is called pets. Let's get back to game state a little bit. Since there's no really one correct order to present all this information in, sometimes I need to jump back to something we talked about earlier. A refresher on what a game state consists of: there's the component multiset, the pending tasks, and I'm going to add to this that we also want to change log everything that happens. When anything changes, we want to record what happened so that we can roll it back later, so that we can experiment with what happens if we do this. And also there's a number of benefits that we get from that we'll get to over time. And so to summarize that again, and if I put them in this order: changelog, components, tasks, it kind of nicely corresponds to past, present, and future. I just realized that the other day. I thought that was kind of neat. The game engine just keeps track of those things, keeps track of what happened in the past, what's happening in the present, or what exists in the present, and what we're waiting for in the future. And it coordinates the changes to those things with integrity. It doesn't let them get out of step with each other. And it executes instructions that modify them all appropriately. Then there's this thing called a REPL, or a command line interface. I think REPL stands for read, evaluate, print, loop. And most programming languages have them. If you program in a certain language and you aren't familiar with your language's REPL, you probably should be. They're very handy. But for this thing, it's just basically a command line UI, and I have to put it in quotes because it's like the worst possible UI you could make. And that's all I'm really going for. I'm not trying to make it a good UI. I just need some way to interact with the library that I created. So you can go there, you can start a game, you can do some stuff. The way that I have currently conceived of the REPL is that you can operate it in a number of different modes. In order to experiment around with a game state, there are several different perspectives that you might want to interact with it at. And each perspective after the first one sort of reduces the number of different things you can do, but increases the integrity of those choices or the correctness of them. So in the yellow mode, we have state integrity, which means we can't use it to create a completely patently bogus state. Like we can't take a plant and put it on top of an ocean tile because that doesn't make any sense. That's defined as being categorically, patently nonsensical. But you can still, you can still do states that could never actually be reached in a real game, like fill up the entire board with city tiles. The point is that a city tile being on any of those spaces is not fundamentally intrinsically wrong. It's only wrong for more, high-level reasons. In any case, when you go up to green mode, now we have task integrity, which means you can tell the thing to do anything you want. You can be like, now I'm going to place an ocean tile. Now I'm going to take a plant. Now I'm going to take 700 money. You can do whatever you want, but then the consequences of that are going to happen. So, for example, if you place a greenery tile, you're going to raise the oxygen. And then when it raises the oxygen, it's going to give you a Terraform rating. So whatever you choose to do, it's going to carry out all the effects of that. That doesn't happen in the yellow mode. In the blue mode, we have turn integrity, which means all you can do is say, hey, I'd like to take a new turn now. And then you can only do things that you could do in a regular turn, like use a standard project, play a card from your hand, turn 8 heat into a temperature raise. You basically initiate one of the standard actions and then you follow all the consequences of it until your whole task list is empty again, and that ends your turn or your action. Action's a better term for it. So it doesn't let you just, hey, I'd like to take 600 money. You would have to do something you can normally do on a turn. But you can still just like, I'd like to take 18 turns in a row. Okay, it'll let you do that because it only has turn integrity. It doesn't have what purple mode is going to have, which is game integrity, which means the engine would be orchestrating the whole workflow of the game. And if you've already taken 2 actions, then it's the next player's turn, unless they passed, in which case it's the next player's turn, etc. So in purple mode, you will not be able to do anything that you couldn't do in a real game legally. And since that sounds so like such a highly useful and advanced feature, it should be unsurprising that we do not have purple mode yet. There is no such thing. That is a long-term aspiration that we may get to. But even without purple mode, these 3 modes give us a fun sort of playground sandbox experience where we can just start setting up scenarios and playing things and seeing what happens. And that's pretty useful. There also isn't a red mode. I skipped over it. You can tell this is sort of in rainbow order. And I skipped over red mode. If there is ever a red mode, it's basically like who let the cat on the table mode. Anything might be on anything. You might have raise the temperature to 10 billion kelvins. Who knows? I don't know whether we need a state like that, so there isn't one right now. If you are interested in anything I've just said, you're supposed to be able to just clone the project. The URL to it was at the beginning, or however you found this video. I'm sure it's in the video description or etc. You're supposed to be able to clone it and then just run the REPL, which is actually called Rego. It probably won't work because there'll be something different about your environment from my MacBook. And, in the Gradle world, builds are not really hermetic, so it'll probably fail. And you can contact us through any of the means that we list on our site, including our Discord channel, and we might know what to do about it. It's tough to say. Like, I haven't used Windows in 20 years, so if you have a Windows-specific problem, I'm not going to be the one to be able to figure it out. But hopefully you can get it working one way or the other. I would love for you to be able to try it out. If it works, you can type help or help and then the name of a command. There are some docs you can read, not very many. There is a Discord. The link is on the GitHub page. As I am narrating this on May of 2023, like no one is using the Discord for anything because no one really knows about this thing yet. So you don't have to worry that it's going to generate a ton of notifications or anything like that. And I don't know what I'm supposed to ask you to do, like and subscribe or star the GitHub project or whatever you want to do to keep yourself in the loop, or I don't know. I'll leave it at that. That's the end of this presentation. I will hope to record more on a variety of topics and perspectives over the coming weeks. Thanks for watching. How do we stop this thing?